You watch a Python tutorial and everything makes sense. Variables, loops, conditions. You understand all of it. But then you try to solve a problem on your own. And suddenly, you don't know what to do. If that happens to you, you're not alone. And more importantly, you're not the problem. Most people think, I just need to learn more Python. So they watch more tutorials, take more courses, write more notes. But the problem doesn't go away because the real issue is not Python. It's something deeper. By the way, my name is Komel. I've been working with code for over 2 decades, and I've seen this pattern again and again. Beginners don't struggle because coding is hard. They struggle because no one shows them how to actually think through problems. That's what we're fixing here. When you watch a tutorial, your brain is in recognition mode. You see code and it feels familiar. Yeah, I get this. But solving problem is different. It requires creation. You're not recognizing anymore. You have to produce the steps yourself. And these are completely different skills. Understanding something doesn't mean you can create it. Watching code feels productive. And to be fair, it does help at first. You see a loop and think, okay, I understand this. You watch someone solve a problem and everything feels clear. But then something happens. The video ends, you open your editor, you try a similar problem, and it doesn't feel clear anymore. Why? Because watching and solving are not the same activity. It's like watching someone solve a puzzle. While they're doing it, everything feels obvious. But when you try it yourself, you don't even know the first move. Or like watching a cooking video. Everything looks simple, but when you actually start cooking, you begin to ask, what comes first? How much? Did I miss something? Something like that. Programming is the same. Watching gives you familiarity. Solving requires control. Watching creates confidence. Solving reveals whether it's real or not. This is the real moment where things break, the blank screen. You read the problem and ask, what should I do first? And there is no clear answer. This is where most beginners think, I don't know enough. But that's not true. You're missing a way to think. Let's take a simple problem. We want to find the largest number in this list. Most beginners look at this and say 23 is the largest. Easy. And then they think, okay, how do I write this in Python? And this is exactly where the mistake happens. You solved it as a human by looking at everything at once. But code doesn't work like that. To help you, now imagine instead of 6 numbers, you have 600 numbers. Can you just look and note the answer? No. Now you're forced to do something different. You have to go through them one by one. So, this is the way that we need to think about the problems, not as a human. But we need to actually remember from the other video that the CPU can just do instructions one by one. Imagine this is inside the CPU. These blocks are instructions. Each one is a very small, very specific action. Now watch carefully. The CPU takes one instruction, executes it, then moves to the next. Execute, move. Execute, move. And just go on. So it can't look at the problem as a whole. It needs to actually break it down and goes one by 1. So because of that here, for all of these numbers, we need to go through them and check. For example, this is our first number. The 7 could be a candidate for our largest number. We keep it in our mind and then continue with 2. Okay, it is not the one. 23. Now this one is going away, and now we have 23 as a candidate. We continue with this, and we just see that, okay, 23 is the largest up to now. But then we found this one. So 23 is not the one. So 73 is the largest until here. So we'll continue and we reach to this one. So that is the winner. And then continue. And we do this for all of the numbers, one by one. That's the real solution. Not 23 or not 101, but the process that guarantees finding it. Programming is not about seeing the answer. It's about defining a process that works even when the answer is not obvious. Let's look at another problem. We want to find the largest common prefix among these words. Again here, we only have 6 words, but this is not the way that we need to think about it. We need to actually consider this as we have thousands of words. How can we solve this problem if we have thousands of words in this problem? So we need to go one by one. We consider the first word and say, okay, it could be our common prefix, the whole word. And then we go to the next one and find the common part. The common part is only 4 letters, COMM. We will continue, and in another word, so we could see that it's reduced to 3 letters, COM. And then we continue. We can see that again we have those 3 letters here. And here, even we have that. But here, in connect, we see that we have only 2. So if we have other words, we will continue this process until the end of the list of the words. So now we know that for these 6 words, this is the longest common prefix. So you see, we didn't solve it in one step. We reduced the problem step by step. Instead of solving everything at once, we kept shrinking the problem. So let's see another example. So in this problem, we want to check if a number is a palindrome. What does that mean? It reads the same from both sides. For example, number 121. Okay? Again, we need to break down the problem. So imagine that we have a long number. Something like this. So here, we need to actually compare the pairs. The first digit and the last digit, whether they are the same or not. Then we go to the second digit and the second last digit, and then move inward and check all of the pairs together. So here they are the same. For 5s, they are the same. For 3, same. And for 1s, they are the same. And 6 is in the middle. If all match, the number is palindrome. If just one of them doesn't match, it means that we don't have a palindrome number here. So again, the same pattern. We turned it into small, repeatable checks. You see it? Every problem can be broken into small steps. And the moment you stop trying to see the answer all at once and start defining the process, everything becomes clear. Good programmers don't look for answers. They build processes that always lead to the answer. If this way of thinking helped you see programming differently, make sure to like the video and subscribe, because This channel is all about helping you think like a programmer, not just memorizing the code. Most beginners skip this step. They jump directly into code. They try to remember syntax instead of building the logic. So they get stuck, not because the problem is too hard, but because they never define these steps. So we want to do this here. We want to shift from I need more Python to I need clearer steps. Programming is not about knowing more commands. It's about organizing actions. Once the steps are clearer, the code becomes much easier. And here's something even more interesting. All programs, no matter how complex, are built from just a few types of actions. In the next videos, I'll show you exactly what those are and how to use them. If this way of thinking clicked for you, you can join my community. That's where we go deeper into this. We practice solving problems, we break things down step by step, and we do weekly coding sessions together. So if you've been feeling stuck, it's not because you're not capable. You just missed one step. And now, you know what it is. I'll see you in the next video.